Today we are going to discuss current electricity worksheet. So the first question is 1B. If you haven't read this question, please pause the video and read it. Basically, an IV characteristic graph of a resistor and a diode are given. They are asking you to determine the resistance of the diode for a potential difference of 0.6 volts. Now we know that V is equal to IR. So if you want to find resistance, you need the voltage and the current. The voltage value is given 0.6. So you need to know the current corresponding to 0.6 volts to find the resistance. And you can use the graph. So you find the 0.6 volts line, this line here, and you find the corresponding current value. So this point is the corresponding this is the point where it intersects the curve. So if you follow it and if you try to find the corresponding current value, that is 7.5. okay, so that's done in the mark scheme. So from V is equal to IR, you substitute 0.6 volts and the corresponding current value 7.5. The only thing is this milliamp thing, so you need to convert it to amps. So there is 10 to the power minus 3. It will give you 80 ohms. Describe qualitatively the variation of the resistance of the diode as V increases from 0.6 to 0.75. So 0.6 to 0.75. We learned that the gradient of an IV graph is the inverse of resistance. Why? We have learned it many times. So V is equal to IR. So from this, R is equal to V over I. Now if you have an IV graph, then the gradient would be y over x, that would be I over V. Now I over V would be 1 upon R. So the gradient denotes the inverse of the resistance. So if you look at this graph, after 0.6 volts, so here is your 0.6, after means here. So if you look at the region in that, there's an issue here. It looks like a straight line, right? After 0.6 volts, when you look at the graph looks like a straight line. This region looks like a straight line. But we know that for a diode, once you have gone beyond that minimum voltage, like whatever that voltage required to get into forward bias, then the resistance continuously decrease. So this is the IV characteristic graph for a diode. So you can see the resistance here continuously decreasing. because the gradient is continuously increasing, and the gradient denotes the inverse of resistance. But the issue is it looks like a straight line. So those who have mistaken it as a straight line and wrote that resistance remain constant get it wrong. And so those who have answered the question from their knowledge that for a diode it's going to continuously decrease would get the mark. But actually, though it looks like a straight line, if you try to calculate the resistance values, we already calculate the resistance at 0.6, that is 80 ohms. Now let's try to calculate the resistance at 0.7. So at 0.7, if you follow the 0.7 line, the 0.7 line cuts the graph here. So the 0.7 line cuts the graph here. So the corresponding value is, it's like, if you look, it's like a bit less than that number, that line. So that line is 12.5. So a bit less than 12.5. It's more like so we have 10 here, then 11, 12, and between 12 and 12.5. So we can just take it, let's take it as 12.5 for the time being, since we are trying to do it roughly. So if we calculate the resistance value there, so for 0.7 volts the approximate current value is 12.5 milliamps. So if you calculate the resistance, 0.7 divided by 12.5 milli would give you 56 ohms approximately. So now you can see that actually the resistance has decreased. At 0.6 the resistance was 80 ohms, now it is 56 ohms. And let's do it for 0.75 as well. So if we try to locate 0.75, because 0.75 is the last contact point, after 0.75 there is no graph. So 0.75, this here, 2.5 boxes behind 8, 2.5 boxes behind 8. So if that corresponds with the maximum current, that is 15 milliamps. So if you try to calculate the resistance at 0.75 volts, the 0.75 volts corresponds to 15 milliamps. So the resistance is 0.75 divided by 15 times 10 to the power minus 3. That is 50 ohms. So again the resistance has decreased. So 80, 56, and now 50 ohms. So though the graph looks like it's a straight line in this region, it is actually not straight but of increasing gradient, but that means it is a curve, but it looks like it curves so slowly that we do not see the curving. Okay, so don't be deceived by the immediate appearance.